This video will demonstrate how to do a regression analysis using Lisrel and path analytic techniques. The data that we're using for this example is a combination of measurements of social support, temperament, home environment, and how these measurements affect a child's development. So development in this case is the dependent variable. So what I'm going to do now is I'll come back to this data, but I'm going to open up Lisrel 9.2, and then I'm going to import the data from the resilience folder. This is the title of the data, and I'm going to select SPSS as my data file type, and then I'm going to open it. And notice it gives me a rs.lsf, so we want to save that. And I already have done this analysis, so I have one in my folder. And so what you should see is these 4 columns of data imported into Lisrel. And so our next step is that we want to look at some statistics, and we will make sure that the covariance matrix is selected, although we could use the correlation matrix. That would be one that we might want to consider. But most of the time we use the covariance matrix. And so then we can go OK. And what this part of the output does is it provides us with some information about the skewedness and kurtosis of the data. Now I don't want you to worry about these warnings. All these are telling us is that there's more than 15 categories, so that this is not ordinal data. It's continuous data that we're analyzing. And so we have the means and the standard deviations for each of our variables, and then the skewedness and kurtosis values. And we also have the chi-square test of normality for these skew and kurtosis values. And you can see that kurtosis for social support is significant, as well as development. The skewedness for the data is the only one that's really skewed is development. However, I will say that Lisrel by default uses the maximum likelihood analysis procedure or algorithm, and it's very robust to violations of normality of the data. And then we have the covariance matrix. And what the covariance matrix is really just the unstandardized correlation matrix between the variables. And again, we have the means and the standard deviations. So I'm going to minimize this, and then I'm going to go to File and New, and I'm going to select Path Diagram. And then I'm going to call this RS for resilience, and I'm going to save it. And again, I've already run this analysis, so I have this file, but so we know it's now called RS Path. Then I'm going to go to Setup, Title and Comments, and I'm going to label this Path RS for resilience. Then I'm going to go Next. We don't have multiple groups, so we don't have to worry about that. Next. And now this is an important step in the process. When I click on Add and Read Variables, I'm going to bring my variables of social support, temperament, home environment, and development into the program so I can create my path analysis. So when I add the variables, this is an important step. I need to make sure that I am selecting the Lisrel system file. That was the LSF file that we created at the beginning of this analysis. And then I click on Browse, and you'll notice that it's available for me. So I click on that, and then I click on Open, and then OK. So you notice that now I have my variables listed under my observed variables. We also have the constant, but we don't need to worry about that for this analysis. And then I'm going to go and click on OK. Now what I can do is I can bring my independent variables over to the path drawing area. Now my variable development is my dependent variable, so I have to check that. It's the y, and it's sometimes considered an endogenous variable. In other words, these variables are considered to be contributing to development or causing development. And then I come up to my drawing template and I click on my arrows, and then I'm going to draw a path from each of my independent variables. Now the next thing I want to do is go to Setup and then build Simplice. So this is the syntax that will run to produce the path diagram. Notice this is my title, RS. It's going to take raw data from that LSF file. It's going to use that for the analysis. The relationships that I'm looking at is that social support, temperament, and home environment equal development. Or there's paths from each one of these to development. Then I want a path diagram, and then, of course, I want the problem to end. And so then I'll come up here and click on Run Lisrel, and then you can see that I have my path diagram. And you'll notice that these path coefficients are the same as the beta coefficients estimated in SPSS. So if I bring my SPSS output back up, you'll notice that the path from social support to development, 0.447, and if we look at the path, we see it's rounded off to 0.45. And we also notice that temperament, 0.291, 0.29, and finally home environment, 0.563. That's 0.56 here. So these path coefficients are the same as these unstandardized beta coefficients in the SPSS output. Now another important thing that we want to look at is that we also can look at our output file. And our output file will tell us certain information. We've already looked at the first part of this, but now we see additional information. So this is our structural equation. Basically, this is like our regression equation. So we have development is equal to 0.447 times social support plus 0.291 times temperament plus 0.563 times home environment. And then our R square is 0.865. And of course, if you look on the SPSS output, you can see that the R square is 0.865. Okay. Then we have the covariance matrix that's provided. And that is basically the information that I wanted to cover for this first use of Lisrel to run a path analysis or a regression analysis with data.